A part 4 video about structure equation modeling. In this video we will talk 6 stages in structure equation modeling. We will read. Structure equation modeling has become a popular multivariate approach. In a relatively short period of time, researchers are attracted to structure equation modeling because it provides a conceptually appealing way to test theory. If a researcher can express a theory in terms of relationship among measured, variable, and latent construct, then structure equation modeling will assess how well the theory fit reta- reality as presented by data. This section continues the discussion of structure equation modeling by describing a six-stage decision process. The process reflects the unique terminology and procedure of structure equation modeling. The six stages are as follows. The first stage is this, defining the individual construct. The second stage, that is developing the overall measurement model, designing a study of produce empirical result, assessing the measurement model validity, specifying the structure models, and the sixth stage, that is the assessing the structural model validity. This is a figure of the six type of structure equation modeling. First, defining the individual construct, what item are to be used as measured variable. Develop and specify the measurement model. Make measured variable with construct. Draw a path diagram to the measurement model. Third is designing the study to produce empirical result. Assess the adequacy of the sample size. Select the estimation method and missing data approach. Assessing measurement model validity. Assessing line geof and construct validity of the summit model. Here is refined measurement in design new study. Measurement model valid. Proceed to test structure model with stage 5 and 6. Specify structure model. Convert measurement model to structure model. Assess structure model validity. Assess to GOF and significant direct and the size of the structure. Structural parameter estimation. This is the last stage. And refine model and test with the new data. Structure model valid. Draw substantive conclusion and recommendation. Let's talk about in further. The remainder of this chapter provide a brief overview and introduction of these six stages. We will talk in brief. This is a stage 1, that is the defining the individual construct. A good measurement theory is a necessary condition to obtain fully result from structure equation modeling. Hypothesis test involving the structure relationship among construct will be no more reliable or valid than is the measurement model in explaining how these constructs are constructed. Researchers often have a number of established scales to choose from, each a slight variant from the others. But in other situations, the researcher is faced with the lack of an estimated scale and must develop a new scale or substantially modify an existing scale to new contact. In each case, how the researcher select the items to measure each construct set the foundation for the entire remainder of the structure equation analysis. The researcher must invest significant time and efforts early in the research process to make sure the measurement quality will enable valid conclusion to be drawn. Operationalizing the construct. The process begins with a good theoretical definition of the construct involved. This definition provide the basic for selecting or designing the individual indicators item. A researcher operationalize a construct by selecting its measurement scale item and scale type. In survey research, Operationalizing a construct result in a series of scale indicator item in a common format such as the Likert scale or the semantic differential scale. The definition and item derived from two common approaches. Scales from prior research. In many instances, construct can be defined and operationalized as they were in previous research studies. Researcher may do a literature search and the individual construct and identify scale that previously performed well. Most researchers today utilize prior scale published in academic studies. Compendiums or prior scale are available in numerous disciplines. New scale development. Construct measurement can be developed. This development is appropriate when the researcher is studying something that does not have a rich history or previous research. The journal process for developing scale item can be long and detailed. The researcher is referred elsewhere for a more thorough discussion. Pretesting. Generally, when measurements are either developed for a study or are taken from various sources, some type of pre- pretesting should be performed. The pretest should use respondents similar to those from the population to be studied so as to screen item for appropriateness. Presenting is particularly important and scale are applied in specified context. For example, purchases, situation, industries, or other in the where the specify is paramount or in the context outside their normal use. Empirical testing of the pretest research is done in a manner identical to the fine model analysis. Seen discussion on stage 4 later in this chapter. Items that do not have statistically as expected many need to be refined or deleted to avoid these issues when the final model is analyzed. Stage 2, developing and specifying the measurement model. With the scale item specified, the research must now specify the measurement model. In this stage, each latent construct to be included in the model is identified and the measured indicator variables items are assigned to latent construct, although this identification and assignment can be represented by equation. It is simple to represent this process with a diagram. Figure 8 represents a simple to construct measurement model with 4 indicators associated with each construct and the correlation relationship between construct. Let's talk about structure equation modeling notations. A key element in the path diagram is the labeling notation for indicator, construct, and relationship between them. Each software program utilizes a somewhat unique approach, although a standard convention has been associated with LISREL that is simply referred to as LISREL notation. Although widely used notation is uniquely tied to the program used for matrix notation, and those it become unwidely to those with no experience with LISREL. For purpose of this text, we will simplify our notation to be generalizable as possible among all the software program given the whispered use of this notation. However, we have developed a reference guide to notation which is seen for index B along with the conversion between the notation and this notation for interested reader that are available at the website www.parasonicgherd.com here or www.amvastats.com. Table 2 lists the notation used in the text for the measurement and structure models. As discussed earlier, there are three types of relationship. measurement relationship between indicator items and construct, structure relationship between the construct, and correlational relationship between construct. There are also two type of error terms, one related to individual indicators and the other to endogenous construct. Specification of the complete measurement model. Measurement relationship for the item and construct. Correlation relationship among the construct and error item for the items. A basic measurement model can be illustrated as the shown in figure 8. The model has a total of 17 estimated parameter. The 7 parameter include 8 loading estimating, 8 error estimate, and 1 between construct correlation estimate. The estimation for each arrows linking a construct to a measurement variables in an estimate of a variable loading, the degree to which that item is related to the construct. This is the stage stage of structure equation modeling can be thought of as assigning individual variable to construct. Visually, it answers the question, where should arrows be drawn linking construct to variables? A number of possible paths were not specified. For example, there are no paths suggesting correlation between indicator variable or loading of indicator or more than one construct cross loading. In the estimation process, these unspecified loading, there are 19 in total, are set of fixed at the value of 0, meaning that they will not be estimated. This is the covariance, supervision, and co-occurrence. This is the variable x1, x2, x3 and x4. Here is x5, x6, x7, x8. This is the visual representation of measurement model. This is the notation of measurement and structure model. Here is the element, symbol, notation and example. Type of indicator, exogenous, endogenous, Y numbers, and type of relationship, measurement loading, structure path coefficient, correlation between construct, error terms, indicator, construct. Let's talk about the creating the measurement model. Specification of the measurement model can be straightforward process, but a number of issues still must be addressed. The type of question are listed here. Number first, can we empirically support the validity and undimensionality of the construct? Essential point must be engaged in establishing the hierarchical basis of the construct and the measurement. Second is that how many indicators should be used for each construct? What is the minimum number of indicator? Is there a maximum? What are the trade of the increasing of decreasing the number of the indicator? Third is that should the measurement be considered a portraying the construct, meaning that they describe the construct, or seen as explaining the construct such that we combine indicators into an index. Each approach brings with a different interpretation of what the construct represents. The researcher, even with well-established scale, must still confirm the validity and unidimensionality in the specified context. In any scale development efforts, issue as to the number of indicators and type of C construct specification must be addressed. Researchers should always ensure that these issues are thoroughly examined, because any unsolved problem at this stage can affect the entire analysis, often the unseen ways. Let's talk about the structure equation modeling stage 3, that is the designing a study to produce empirical result. With the basic of model specified in term of construct and measured variable indicator, the researcher turn attention to issue involved with research design and estimation. Our discussion will focus on issue related to the both research design and model estimation. In the area of research design, we will discuss number 1, the type of data to be analyzed, either covariance or correlation. The second is that the important and remedies for missing data, and third, the importance of sample size. In terms of model estimation, we will address model structure, the various estimation technique available, and the current computer software being used. here is issue in research design. As with any other multivariate technique such as structure equation modeling, that is required carefully consideration of factor affecting the research design necessary for a successful structure equation modeling analysis. Structure equation modeling can be estimated with either the covariance and correlations. Thus the researcher must choose the appropriate type of data matrix for the research question being addressed. And even though the statistical issues of structure equation modeling estimation are discussed in the next section, here is the important to note that the sample size and missing data can be have powerful effect on the result no matter what method is used. Let's talk about metric versus non-metric data. The observed or measured variable have traditionally been restricted to matrix data, interval or ordinal. This type of data is directly amenable to the calculation of covariance among items as discussed earlier. Advanced in the software program, however, now allow for the use of many non-matrix data type, censored, binary, ordinary or nominal. Different type of variable can even be used as item for the same latent construct. The researcher must be carefully to specify the type of the data being used for each measurement variable so that the appropriate measurement of association can be calculated. Covariance versus correlation. The researcher conducted structure equation modeling analysis in the past, debated over the use of covariance versus correlation matrix as input. Structure equation modeling was originally developed using covariance matrix, hence it is referred to with the common name of analysis of covariance structure. Many researchers advocated the use of correlation as a simple form of the analysis was easier to interpret. The issue had practical significance because for many years the input material were computed using the statistical routine outside the structure equation modeling program, and then the matrix of correlation and covariance was used as input for the analysis. Today most structure equation modeling program can computation model solution directly from raw data without the researcher computing a correlation or covariance matrix separately, but researcher must still choose between correlation versus covariance and the interpretative and statistical issues. Interpretation. The key advance of correlation input for structure equation modeling lies in the fact that the default parameter estimated are standardized, meaning no scale depend, all estimation values must fall within the range 1.0 to 1.0, making the identification of appropriate estimation easier than the covariance which have no defined range. However, it is simple to produce their result from covariance input while requesting a standardization solution, as such correlation hold no real advantages over the standard result obtained using the covariance. Statistical impact. The primary advantage of using covariance arise from statistical correlation. First, the use of correlation as input can at times lead to error is standard error computation. In addition, any time hypothesis concern questions related to the scale or magnitude of value. For example, comparing means the covariance must be used because this information is not retained using correlations. Finally, any comparison between sample required that covariance be used as input. Those covariance have distinct advantages in terms of their statistical properties versus correlations. Choosing between covariance and correlation. In comparing The use of correlation versus covariance, we recommended using the covariance whether possible software make the selection of type versus another just a matter of selecting the type of data being computed. Covariance metric provide the research with the more flexibility due to the relatively greater information content they contain. Missing data. Just as with other multivariate procedure, the researcher must make several important decisions regarding missing data. Two questions must be answered considering missing data to suitable address any problem it may create. The first, the missing data sufficient and non-random so as the cause problem to estimate or interpretation. If missing data must be remedied, what is the best approach? We will discuss the issues that related specify the structure equation modeling and missing data. In the following section, the reader is also referred back to the methods of assessing the extent and pattern of missing data and the approaches to remedy missing data if needed. Let's talk about the extent and pattern of missing data. Most notably, missing data must always be addressed if the missing data are in the non-random pattern or more than 10% of data item are missing. Missing data are considered missing completely at random if the pattern of missing data for a variable does not depend on any other variable in that set of the value that variable itself. If the pattern of missing data for a variable is related to the other variable but not related its own value, then it's considered to missing at random. Missing data remedies for basic method are available for solving the missing data problem. The complete case approach known as the listwise deletion where the respondent is eliminated if the missing data or any variables. The all available approach known as the pairwise imputation technique, for example, means substitution and model based approaches. Traditionally, listwise deletion has been considered most appropriate for structure equation modeling. More recently, pairwise deletion, which allowed to use the more data, has been applied. Both of these procedures can produce problems. Model-based approaches extend past the simple imputation approaches in the missing data are imputed replaced based on the all variable available data for a given respondent. The two most common approaches are the maximum likelihood estimation of the missing and the estimation approaches. Discussion of these imputation method is beyond users put is available in a number of approaches for dealing with missing data exist. Researchers should apply quotation whatever the missing data exceeded 10% because conclusion about fit become increasingly suspect. Structure equation modeling program have also introduced the appropriate within the model is estimated directly from the available data, making allowance for the missing data during the estimation process known as full information likelihood approaches is eliminated the need to remedy the missing data before examination with one of the approaches just described. What there are two considerations is using the approach. First, can only be used when the original data set are available. Cannot be used with only the covariance matrix as input. Second, in many cases it provide only a smallest subset of the statistical which may be inadequate for complete model evaluation. Another consideration in the selecting an approaches is a specification of the sample size. Both the all available pairwise and the model based approaches complicated the specification of sample size because they potentially utilize differing sample size for each covariance term. Structure equation modeling researchers have investigated the variety of effect of setting the overall sample size at the full sample size the large number of the observation, the average sample size and the minimum sample size, the smallest and the associated with any sample covariance. This result generally suggests that increasing increasing interesting the minimum sample size lead to the fewest problem with the covariance bias and parameter estimation. Let's talk about the selecting a missing data approaches. What is the best approach for handling the missing data for structure equation in journal? We should first note that if missing data are random, less than 10% of observation and the factor loading are relatively high. 0.7 or greater than any of the approaches are appropriate. When the missing data are more problematic, then this the first section facing the research is whether to remedy the missing data problem before the estimation process. Table 3 summarized the strength and weakness of each approaches. When applying the remedy for missing data before estimation, the complete case approaches, likewise deletion, become particularly problematic when sample or factor loading are small. Conversely, the advantages of the model-based approaches become the particularly apparent as the sample size and the factor loading become generally smaller and the amount of missing data become the larger. The all available approaches pairwise deletion is recommended when the sample size exceeded 250. This is a table 3. This is the table about the some advantages and disadvantages of different missing data procedure, method, advantages and disadvantages. Let's talk about the first, that is the complete case. Likewise, x square shows the little bias and under most condition effective sample size is non easy to implement using any program. Disadvantages: decrease the likelihood of the non-coverage. Structure equation modeling program cannot find a solution unless factor loading are high, greater than 0.16, and the sample size are the large, greater than 250. Increase likelihood of the factor loading bias. Increase the likelihood bias is estimated or relationship among factors. All available pairwise. Fewer problem with covariance. Factor loading estimate, relatively free bias, easy to implement using any program. X square is based the upward amount of the missing data exceeded 0%, factor loading are highly, sample size is high, effective sample size is uncertain, known as well known. Model based missing data, that is the fewer problem with the covariance, not available on the older structure equation modeling program. Effect the sample size is uncertain to structure equation modeling. X square shows the little bias and more condition, full information, maximum likelihood, that is the remedy directly in the estimation process. This is the advantages, and another advantages is that is most situation has less bias than the other method. This is disadvantage: research has no control and how missing data is remedied, no acknowledge how missing data impact on estimate, typically only the subset of the fit indicate available. Not seen, Anders and the Bandolas to 2001. These are the paper where the more detail of MIN structure equation modeling has been combined based on the negligible differences between the result for the two. The total amount of missing data involved among the measurement variable is below 10%. With this approach, the sample size n should be set as the maximum smallest sample size available for any two covariance. Then all available approaches has many good properties, but the user should be of the potential inflations of its statistical when the modest or large amount of data are missing and factor loading are large. All of these approaches, however, allow the researcher to explicitly remedy the missing data, effort, estimation, and understand the implication of whatever approaches is taken. If the decision is to estimate the model without any remedy for missing data, then the FIML approaches is the best alternative. Here the estimation process is based on incomplete data which may or may not have implication for the result. In the absence of serious missing data problem, all of the approaches produce comparable results if those become as the much a choice by the researcher as the whether to remedy the missing data beforehand or do so in the estimation process. In the author experience, if it is most often used to be resolved missing data issues before the estimation the model. Let's talk about the sample size. In structure equation modeling, structure equation modeling is the same way more sensitive to sample size than other multivariate approaches. Some of the statistical algorithms used by the structure equation modeling program are unreliable with small samples. Sample size, as any other statistical method, provide a bias for the estimation of sampling error. As a starting place in discussing sample size for structure equation modeling, the reader can review the sample size discussion required for exploratory factor analysis. Given that larger samples are usually more time consuming and expensive to obtain, the critical questions in structure equation modeling involving how large a sample is needed to produce trustworthy results. Opinion regarding minimum sample size have varied. Proposed guidelines vary with analysis procedure and model characteristic. 5 considerations affected the required sample size for structure equation modeling include the following. The first, multivariates normality of the data. The second is estimation the technique. Next, model complexity, and next the amount of the missing data, and fifth the average error variance among the reflective indicators. Each of these considerations is discussed in the following paragraph. Here is a multivariate normality. As data deviate more from assumption of multivariate normality, then the ratio of responses to parameter needed to increase. A general concept ratio to minimize problems with deviation from normality is 15 respondent for each parameter. Estimated is the model, although some estimation procedures are specifically designed to deal with the non-nominal data. The researcher is always encouraged to provide sufficient sample size to allow for the sampling error impact to minimize, especially for non-nominal data. Estimation technique. To the most common structure equation modeling estimation process is maximum likelihood estimation. Stimulation studies suggest that under ideal condition, MLE provide, that is the maximum likelihood estimation, valid and stable result with the sample size as smaller as 50. As one moved away from condition with another increase when confronted with the sample errors. Given less than ideal condition, one study recommends a sample size of 200 to provide sound basis for estimation, but it should be noted that as the sample size become larger, greater than 400, the method become more sensitive and almost any differences is delected, making the goodness of fit measurements such as poor fit. As a result, sample size in the range of 100 to 400 are suggested, subject to the another consideration discussed next. Model complexity. Simpler model can be tested with smaller sample. In the simplest sense, more measurement indicators variables require larger samples. However, model can be complex in other ways that all require larger sample size. more construct that required more parameter to be estimated. Construct having the less than 3 measured indicator variable. Analysis requiring an adequately sample for each group. The role of the sample size is to produce more information and greater stability. Once a researcher has exceeded the absolute minimum size, one more observation, then the number of observed covariance, larger sample means less variability and increased stability in the solution. Those model complexity lead to the needs for larger sample. If we talk about the missing data complicate the testing of structure equation modeling, and the use of structure equation model in the journal become in the most appropriate to remedying missing data. The sample size is reduced to some extent from the original number of cases depending when the missing data approach is taken and the extent of missing data anticipated, and even the type of issues being addressed. With many include higher level of missing data, the researcher should plan for an increase in a sample size to offset any problem of missing data. Average error variance or indicators. Recent research indicates the concept of communality is a more relevant way to approach the sample size issues. Communalities represent the average amount of variations among the measured indicator variable explained by the measurement model. The communality of item can be directly calculated as the square of the standardized construct loading. Study shows that larger sample size are required as communalities become smaller, that is, the unobserved construct are not explaining as much variance is the measurement item. Those containing multiple construct with the communalities less than zero point 0.5, that is standardized loading estimation less than 0.7, also require larger size for conversion and model stability. The problems is exaggerated when the model have construct with only one or two item. Summary of sample size. As structure equation modeling, measure and additional research is undertaken of key research design issues, previous guidelines such as always maximize your sample size and sample size of 300 are required are not less than no longer appropriate. It is still true that larger sample generally produce more stable solutions that are more likely to be replicable, but it has been shown that the sample size discussion must be made based on set of factors. Based on discussion of sample size, the following suggestion for minimum sample size are offered based on model complexity and basic measurement model characteristic. Minimum sample size 100, modeling containing 5 or fewer construct each with more than 3 items observed variable and with higher item communalities as zero point 0.6 or higher. Minimum sample size 150, model with even construct as less. Model communalities 0.5 and no underridden identification construct. Minimum sample size 300, model with 7 or fewer construct, lower communalities below 0.45 and multiple underridden identical fewer than the construct. Minimum sample size 500, model with larger number of constructs, some with lower communalities and having the fewer of 3 means of the item. In addition to these characteristics of the model being estimated, sample size should be increased in the following circumstances. The first, data deviates from the multivariate normality. The second is sample intensive estimation technique, we call it ADF, are used of the or the 3 missing data exceeded. 10%. Also remember that group analysis required each group meet the sample size requirement just discussed. Finally, the researcher must remember that the sample size issues goes beyond being able to estimate a model. The sample size, just as with any other statistical interface, must be adequate to represent the population of interest and may often to be overriding concern of the research. Let's talk about the issues in model estimation. In addition, more journal research design issue discussed in the prior section. Structure equation modeling analysis has several unique issues as well. These issues related to the model structure, estimation technique used and computer programs selected for the analysis. Model structure, among the most important step is the selecting of the structure equation modeling analysis is determining and communicating the theoretical model structure to the program. Path diagram like those used in the prior example can be useful for this purpose. Knowing the theoretical model structure, the researcher and then specify the model parameters to be estimated. These models often include common structure equation modeling, abbreviations denoting the type of relationship or variable referred to. As discussed earlier, notation is widely used for the notational form of guide to notation is available of the website. As we have as we have mentioned many times, the researcher is responsible for specifying both the measurement and structure model. The process varies between different user and the software programs, ranging from a heavy reliance on syntax and matrix notation in LISREL to those using AMOS with a completely graphical interface. But no matter what approach is taken, each approach is performing the same function specifically, which model parameter to estimate for every possible parameters. The researcher must decide if it is to be free or fixed. A free parameter is one of the estimated model, where a fixed parameter is one in which the value is specified by the researcher. Most often, a fixed parameter is set to the value of 0, indicating that no relationship is estimated structure equation required. The each possible parameter to specify as estimated or not. Yet, no matter which software is used, the researcher must be able to specify the complete structure equation model in terms of each parameter to be estimated. Estimation technique. When the model specify, research must choose the estimation method and mathematically algorithm that will be used to identify estimation for each of free parameters. Several options are available for obtaining a structure equation solution. Earlier, attempts at structural equation model estimation were performed with ordinary least square. We call it OLS regression. These efforts were quietly supplanted by maximum likelihood equation, which is more efficient and unbiased when the assumption and the multivariate normality is met. MLE is a fixable approach to the parameter estimation in which the most likely parameter value to achieve the best model fit are found. The positive sensitivity of MLE to non-normality, however, create a need for alternative estimation technique. Methods such as weighted large square, we call it WLS, generalized large square GLS, and sympathetically distribution free ADF and estimation become available. The ADF technique has received particularly attention due to the intensivity to non-normality of the, but it's required of larger sample size limit its use. All of the alternative estimation techniques have become more widely available as the computing power of the personal computer has increased, making the feasibly for typical problems. MLE continue to be most widely used approach, and its default is most structure equation modeling program. In fact, it has proven fairly boost to violations of the normality assumption. Researchers compare MLE with other technique and produce reliable result under many circumstances. Let's talk about the computer programs. Several readily available statistical programs are convenient for performing structure equation modeling. Traditionally, the most widely used program, that is the LISREL, we call it linear structure relation, and is a fixable program that can be applied in numerous situations, that is cross sectional, experimental, quasi experimental, and longitudinal studies, and has become almost synonymous with structure equation modeling. We call it EQS. Actually, an observation for equation is another widely available program that also can perform regression, factor analysis, and test structure model. Amos analysis of movement structure, that is the program that gained popularity, becoming additional to being a module in SPSS. It also was among the first structure equation modeling program to use the graphic interface for the function of, so that a researcher never has used any syntax commands or computer code. Multiple in a modeling program with multiple techniques that had also a graphical interface. Finally, CALIS is the structure equation modeling program available within SAS. Ultimately, the selection of the structure equation modeling program is based on research preference and the availability. The program are actually become more similar as they involve Amos structure equation modeling and the LISREL are all available with the points and click interface available, and the ability to specify and modify the model through the interactive path diagram. The principal difference is the notation used in the specifying the measurement and structure model. LISREL use Greek letter to represent the latent factor error terms and parameter estimated, and the Latin letter X and Y to represent observed variable known as the LISREL notation is provide a convenient shorthand for describing model and simplify discussion considerably once is familiar with the notation. The other program rarely less to Greek abbreviation and make greater use are different approaches to both model specification and reporting of the result. Today, all of these programs are available in version that can easily be run off virtually and PC for most standard application. These programs should produce similar substantive result. An appendix available at the website www.parasonysites.com. Here www.mvstats.com provide example of the commands needed for several of these programs. This is a thumb rule. We call it the structure equation modeling first and three. When model has scaled, borrowed from the various sources reporting other research, a pretest using the respondent similar to those with the population to be studied is recommended is screen item for appropriateness. Pairwise deletion of missing cases, all available approaches is a good alternative for handling the missing data with the amount of missing data is less than 10% and the sample size is about 250 or more. As sample size becomes small or when the missing data exceeded 10%, one of the imputation method of missing data become a good alternative for healing missing data. When the amount of missing data become very high, 15% more, structure equation modeling may not be appropriate. Covariance matrix provide the research with more flexibility due to the real greater information content they contain and are the recommended from the input structure equation modeling. The minimum sample size for a particular structure equation modeling depends on several factors including the model complexity and the commonalities, average the variance extracted the items in each factor. Structure model containing the 5 or fewer construct each of more than 3 item observed variable and with high item commonalities zero point 0.6 or higher can be adequately estimated with the sample as small as the 100 to 150. When the number of factors is larger than 6, some of the which have fewer than 3 measurement items as indicator and multiple low commonalities are present, sample size requirement may exceed 500. No matter the modeling approaches, the sample size and sufficient to allow the model to run, but more important is must adequately represent the population of interest. Stage 4, that is the assessing the measurement model validity. With the measurement model validity, sufficient data collected and the key decisions such as the estimation technique already made, the researcher comes to the most fundamental event in the structure equation modeling testing. It's the measurement model valid. Measurement model validity depend on the establishing acceptable level of goodness of fit for the measurement model and the finding the specified evidence of the construct validity. Because we are focusing on the structure equation modeling in this sample example, we will defer the investigation of construct validity until another time. The following discussion will focus as assessing the goodness of fit the overall model. Goodness of fit indicate for well the specified model reproduce the observed co- convariance matrix. Among the indicator item, that is the similarity of the observed and the estimation covariance matrix. Ever since the first goodness of fit measure was the developed, researcher have strived to define and develop the new measurement that reflect the various facts of the model ability to represent the data. As such, a number of alternatives, that is the goodness of fit measure, are available to the researcher. Goodness of fit measuring is unique, but the measurement are classed into the journal group: absolute measurement, incremental measurement, and the parsimony fit measurement. In the following section, we first review some basic element underlying all the goodness of fit measure, followed by the discussion of each class of the goodness of fit measure. Readers interested in more detailed and statistical based discussion are referred to Appendix C. The basic of goodness of fit. One specified model is estimated. Model fit compare the theory to reality by assessing the similarity of the estimation covariance matrix theory to reality, the observed covariance matrix. If a researcher theory were perfect, the observed and estimated covariance matrix would be the same. The value of any goodness of fit measurement result from a mathematical comparison of these two metrics. The closer the value of these two metrics are to each other, the better the model is said to fit. We start by examining the chi-square, since it is a fundamental measurement of differences between the observed and estimation covariance matrix. Then the discussion focus on calculating degree of freedom, and finally on how statistical interface is affected by the sample size, and then impute the provides the alternative of goodness of fit measurement. Chi-square. Goodness of fit, the difference in the observation and estimation of covariance matrix termed S and the sigma ky respectively. It is the key of value assessing the goodness of fit on the structure equation model. The chi-square test is the only statistical test that the difference between the matrix in structure equation modeling and represented mathematically by the following equation: x2 by the observed multiple covariance matrix and structure equation modeling, that is the variance matrix. It should be noted that even if the difference is covariance matrix, that is the residual remnants content, the x square value increase, the sample size increase. Likewise, the estimated covariance matrix is influenced by how many parameters are specified, that is the free in the model. So the model degree of freedom also influence the goodness of it. Degree of freedom. As with other statistical procedure, degree of freedom represent the amount of mathematical information variable to estimate model parameter. Let's us start by reviewing how it is calculate. The number of degree of freedom for the structure equation modeling is determined by df is equal to 1 by 2, that is the p, and p plus 1 is equal to k minus k, where the p is the total number. What is the p? P is the total number of the observed variable, and k is the number of estimation free parameters, and subtracting the number of estimated parameter from the total amount of available mathematical information is similar to other multivariate method, but the fundamental differences in structure equation modeling comes in the first part of the calculation. 1 by 2 p and p plus 1, which represent the number of covariance term below the diagonal is 1 plus the variance of the diagonal. It is not derived at all from of sample size, as we saw in other multivariate technique, that is the regression. Df is the sample size, minimum number of estimation coefficient. The degree of freedom of structure equation modeling based on the size of covariance matrix, which come from the number of indicators in the model. An important implication is that the researcher does not affect the degree of the freedom through the sample size, but we will see later how sample size influence the use of chi-square as the goodness of it measurement. Let's talk about the statistical significance of sigma x square.